First, create a new project directory and run npm init to create a new package.json file. Install all dependencies we need, like this. You can simply copy this line from the description. While this is installing, we can create index.js file and start develop server. Each GraphQL server needs a schema. The schema defines the types of the data that client can query and the operation they can perform. Type devs is a string that describes the available data and the structure of the data. Resolvers is an object that defines how the server should handle each GraphQL field in the schema. Let's create these files. Two main types of request: queries and mutations. Query is used to request data from the server without changing any data. The mutation, on the other hand, is used to modify data on the server. Let's create first query hello that will return string. Okay. Define a resolvers object to map the hello query to a function that returns a string. In order to use Apollo server, you need to provide it with a schema. After, we can start our server using immediately called anonymous function. Let's run npm start. Oops. It looks like I forgot to add start script in package.json. I guess I missed something. Let's take a look. And yep, I forgot to add server apply middleware If we use Express, we have to do it. Yep, welcome to GraphQL Playground. Here you can explore your API by sending queries and mutations and see the result displayed in right-hand panel. It's similar to Postman. We use Postman to test REST API, this playground for GraphQL. You can also view documentation about your schema in the left-hand panel and run queries directly from the documentation. And server returns hello after a called query hello. Let's take a look at our frontend. Here we have to set up Apollo client with React. In this tutorial we're gonna use two components, chat component and message list. The chat component shows the messages between two users. The message list component provides us a list of users which can be used to select a chat to view. Let's create a new folder GraphQL. Inside Apollo client.js. And let's see what we can find in documentation. We have to import a couple of things. Then initialize our Apollo client.
Okay.
And provide this client to React application. Let's import all links that we have to provide to Apollo client. Copy this link. This instance creates an HTTP connection to the server. Graphql-ws link creates a WebSocket connection. The auth link will add authorization header to the request. The setContext function allows us to dynamically modify the context of the request. We will save JWT token in local storage. And returning new object with headers. The last thing what we should do is paste split function to determine whether a request should use the WebSocket or HTTP connection. And pass it to Apollo client. Let's check if everything is okay. We set import. In DevTools we can check if we already have WebSocket connection, and yep, it's good. Let's write hello query on frontend. We have already written it on playground. Again, forgot it imports. Also we lose sign of at our server URL. Let's pass it here and here. And we receive response hello. Now we can create MongoDB database. Connecting to database is very simple. Just paste copied link into Mongoose connect method. Now we're gonna create modules folder for collections. First we're gonna create user.js file. This will contain the code for defining the user model. Go to MongoDB. And inside MongoDB we can find users table. Let's quickly refactor resolvers. Okay, now we can create a new user using user sign up mutation. User sign up mutation will return an object with user information. Let's describe this type. It remains to write logic in resolver. We do not need parent parameter. From second parameter we can extract passed arguments. And create a user with this input. Also, don't forget to describe the types of arguments in typedevs. And that's all. Go test it. Checking database. So the result is new created user. I think now we can create a new query, get all users to get an array of all created users. Let's call it now. And it works fine. I want to create one more user. Running again. Yep, it works. The next thing what we should do is implement login query. We will return an object user and JWT token. And next query is user aus query to get an information about logged in user. But before writing resolvers, let's create a context and pass it to Apollo server. Trying to find a token from authorization header. If so, we will add a user object to context. And here I can get context. Destructuring the user object from context. Looking for user in database. let's implement login, getting email and password from arguments. Trying to find the user in database by email. And we have to check if passwords match. But before, we should hash passwords in signup and store hashed password in database instead real password. Just want to check if we hash password correctly. Yep, it works. Nice. Okay, go finish implementation of login query. Checking if passwords match using bcrypt compare method. The last thing what we should do is create JWT token and return it to the client. That's all. Let's test it. I was wrong here, we need to find one user. On client, we will attach this token to authorization header. So now we can check user auth query. But before a test on playground, we should set authorization header. And context works perfect. Let's write these queries on frontend quickly. We already have two pages, login and sign up. Let's do it. Okay, let's see what we get in response from server. Yep, we get user info. Let's log in immediately after sign up. We will save the received token in local storage. Just duplicate login logic to login component. The next thing what we gonna do is saving information about logged in user in global state. In this tutorial I am using Recoil, but you can use any library or React context. Let's implement our route that will redirect depending on whether user is logged in or not. Let's wrap our components in our route. Checking how it works. Something is wrong because we are redirected to the login page. And in the request I can't find authorization header.
"2,000 years later."
Now if user logged in, each request contains authorization header with JWT token, and it remains only to implement the logout function. And that's simple, just set ws null and remove local storage item token. We can already change this with logged in user information. Beautiful. Now we can implement the most interesting part of this tutorial, sending and receiving messages. We're gonna start by creating a new model message.js. Now we will create a new file with resolvers for message operations. Nice. Go to typedevs file. We're gonna start with send message mutation that will accept receiver ID and message content. Sender ID, that is the logged in user, we can take from context. And returning message. Let's describe type message. We also need message by user query in order to get an array of messages. Let's start with send message mutation. Everything is obvious here. In message by user, we can extract messages between two users from database. But before, we have to get the receiver ID and token. So let's do sign up and login. Running. Boom, it works. Now let's try to get an array of messages between two users, calling message by user. Perfect. It remains to add that to the frontend. Now we're gonna create a new file message.js and write queries there. The next thing, we will implement onClick function, select chat ID. Great, the chat ID changes when I click on user. And we're ready to get messages and send message. Let's do it. Call get messages in useEffect. The message has been sent. Let's look at the operation of get messages query. And I don't see this message.
Two 2,000 years later.
The problem is that we need to make request every time when user select chat. Perfect. Let's see if this message was picked up by Stepan. I don't see our messages in chat with other users. That's okay. And in the chat with the test user we see these messages. Let's try to send message with Stepan. And let's see if the message appeared in the test user. Is not. But if we refresh the page, the get messages query will return to us all messages. That's correctly. But we don't get message in real time. We can implement this functionality by using GraphQL-subscriptions in the next part of this video. In this part we will implement real-time messaging using GraphQL-subscriptions, which will allow our users to see new messages as they arrive, without need to manually refresh the page. Subscription new message takes two arguments, a receiver ID and ws ID, and return a message object when a new message is added. Now let's write a new message resolver. In our resolver for the new message subscription, we are using the wsFilter function from the GraphQL-subscriptions package to filter the incoming subscription events based on the variables provided by the client. And PubSub. It allows the server to publish messages to the channel, and then clients can subscribe to that channel and receive the messages. Inside the wsFilter function, we are first calling PubSub async iterator with new message to create an async iterator that listens for the new messages events published to the PubSub instance. We will publish PubSub in the send message mutation. Then we are using a callback function to determine whether each event should be filtered based on the variables object provided by the client. And it returns a boolean value. In the send message mutation, as I said before, we use PubSub publish to publish the message to the new message topic along with a new message that contains a message object. So now we can get a new message from payload. From variables we can get receiver ID and ws ID. In our case, the filter function should check whether the new message was sent by authenticated user or received by authenticated user. If so, the client is eligible to receive the event. That's all. Go to frontend and write this subscription. In the use subscription hook, we pass the new message subscription constant we created earlier, along with the receiver ID and auth ID variables to filter the subscription's results to only include messages between two users. In the on subscription data, we can console log this data to check if it works. And when we send a message, now we will receive the object of this message in the console. Nice. Let's see if it works the same in the user to whom the message was sent. But before, we should select chat with test user. Sending message from Stepan to test. And we see that the subscription returns messages for two users. And all we have to do is render these messages in markup. Final test. Oops, something is wrong, because the sender should see these messages on the right and with other styles. But the subscriptions works fine, because a message appeared in the test user. Yep, that's good. Yes, the problem is that subscriptions returns only the content of the message and the ID, without the sender ID and receiver ID. because here we specified exactly this data to return. Testing how it works now. This message confirms that our subscriptions is working as expected and that we have successfully implemented real-time messaging with GraphQL. So, in this tutorial we learned how to create a real-time chat application using GraphQL and MongoDB. We created a schema with notation for user sign-up and sending messages, as well as a subscription for real-time updates. We also implemented authentication using JSonwebtoken and learned how to use Apollo client to query and rotate data from the frontend. Thank you for following along and happy coding!